Alright, welcome to another walkthrough room. This one's Overpass2 hacked. Pretty interesting room. It has kind of two parts, similar to the other Overpass rooms. You analyze a Pcap file. You find information in that Pcap file that then helps you kind of get access to the actual box. This is a somewhat guided challenge room. Gives you a little bit of questions and has hints, and requires you to kind of answer a couple questions in order to understand better what happened. This is a good room, I think, for blue teamers or red teamers, people looking to do SOC or pen testing, because you can kind of see from the SOC side what happened, how to analyze that data, if you're given a Pcap maybe of traffic happening, and for the pen testers or red team side, you can kind of see where maybe things look like in an actual packet capture. So let's get started. Let's look at this room. Here's the room on TryHackMe. Again, it consists of multiple tasks and multiple questions and answers. So the first part here is that we downloaded a Pcap file. We're going to examine this. We'll be using Wireshark for this. And then the second part, we'll research and analyze some of the code that we found in the backdoor, and then we'll actually get in. So let's start analyzing the Pcap. The first thing that this is asking for is the URL of the page that was used to upload a reverse shell. So I've already opened up the Pcap file in Wireshark, and you can do that via a couple ways. You could open up Wireshark and then go to File and open up the actual Pcap, or on the command line, you can put in Wireshark-R and then the Pcap file, and that will spin up the GUI version of that. If you never used Wireshark before, sometimes it does catch people off guard. They don't know, what they're looking for on how to look for data or how to filter that or do anything with that. Wireshark has a display filter. So first off, this is a Pcap file. So this is network traffic between that was captured, and that's then broken down into packets, and those packets are then visually displayed to you and broken down, via the OSI layer there. So you can see we're looking at packet 1. There's the time, and the time is based off of whenever it was captured. So 0 seconds, and then 0.000012. So basically some milliseconds. The source is where it was whatever box that it was doing the capturing, where it determines that that's coming from, and then where it's as basically going to talk to. Protocols are going to be the actual way of communication. Length is how big is that packet. And then what you're seeing here is the port number talking to whatever port, and then and if it's TCP, then of course then you have your flags, and then the additional informations like sequence number, when, length, MSS, so on and so forth. So each one of these is broken down here in this GUI version here, and like I said, you can go into each portion of the layer here. So you could go down to frame 1, and if you wanted to see where the frame number is at, you can click on that. You can click on the frame length, so on and so forth. So like we could click on, here's Ethernet, and there's the source and destination. So there it is in the packet. It shows you exactly, kind of highlights it there. So you'll notice 000C, 29, and then 6E, 18. And so this is kind of showing you right here that that's the address portion, the destination. And then same thing, if you were to look at the source, then that highlights where the source is at. Okay, so getting back to the actual question, what we're looking for is the URL of the page that was used to upload a reverse shell. So URL implies that we're looking at HTTP. So we could even filter this down a little bit. In this display filter bar up here, is where we can put in HTTP. We can do, let's see here. Where's it at? Nope. That's create a label. I don't want to create a label. What I'm trying to do is create a filter and just show that data. There we go. Display filter. So here's field names. Again, what we're gonna kind of look for is see if we can find HTTP here. There we go. And we can just leave that as is present. That's what I was trying to type in earlier in the search bar. So you'll see that that's green. So I have my term correctly, but you'll notice nothing changed. I have to push enter. And now you'll just see only the HTTP protocol. So again, this can help you out to find certain data. It can also mess you up if you're looking for something and forgot that you had this filter. So again, just be cognizant of that. So again, we were looking for a URL, and so what we can kind of see here is in the info part is some of the actual request, and we can just go through these or figure it out. So the first one is development, and the data is down here, and you can kind of read this, but it might not be completely readable to you, or you want it in a better format. So what you'll do then is you can right click on that packet and then go to follow and then do either TCP stream or HTTP stream. Usually I do TCP stream because then that just gives you a better context and you see. So the red portion here is what the request was to the server, and then the blue portion is what came back. So in this case here, it doesn't look like that's what the attacker uploaded. So we can close this one. And what we'll notice now is that our filter changed, and you'll see that this says tcp.stream equals 0. And so this is the communication back and forth for that stream. So going from the source to the destination and getting that information back. Again, if we need to go back to where we were at, we can clear out this filter by pushing the X. We can put in the HTTP again and push enter and move down to the next one. So this one is a development slash upload, and we again can see some of this data here. Some of the juicy bits that you can already see in the packets or in the data here is the PHP exec, RM, so on and so forth. So this kind of looks like what this is asking for, but maybe you can't read that as good, or you want to get the complete context or see that more. So again, we'll click on that, we'll right click on it, and then do follow. I'll do HTTP stream this time so you can see the difference. And there we go. So we can see that someone made a post request to development upload, and then in that they did form data, which is basically uploading data to like a form, and they uploaded payload.php, and in there had the PHP exec, and it's basically a reverse shell, netcat reverse shell using this portion right here. So this is a binsh reverse shell using netcat. So that file then got uploaded. The server responded with an OK, and then it uploaded. And then the next thing the person did again is a get to uploads to look at that directory. And this is the response back. So we can see that it had the response. And that's all we see here is that there was the payload.php. So basically, they were after they uploaded, they just went to the uploads directory. So based on the task, what we're trying to find out here is the URL of the page they used to upload a reverse shell, and it just looking like they're not looking for the actual PHP. So what we can do is development then, and let's see if that works. So we'll copy this from here. And that was good. What payload did the attacker use to gain access? So again, we can see this is very long. This is going to be the exact same payload that they did in here. So we're going to just copy this whole thing. All right, did not like that, so let's see if there is additional hint. Include PHP tags, whole file content. Okay, so it wants everything. That's a good hint, I think, because again, you're asking someone to kind of read your question, interpret it, and then figure out, well, what do you want? As someone that's maybe experienced, I see that they uploaded a reverse shell, so that's immediately where I went. So that I think that hint does kind of provide the user the ability to kind of know exactly what they're looking for. Uh, what password did the attacker use to privsec? So we can't see that currently in our span because we only got the communication of when they uploaded that back and forth. So what we can look at here is again we can go back to the Wireshark and a cool little trick that I'll kind of show you here is again we did tcp.stream equals 1. If we do equals 2, we can go ahead and change to the next stream. And again, a stream is usually going to be a collection of packets that actually have data on them and stuff like that. And we can then follow that and see if we get any more information. So in this case here, we're not really seeing anything in this stream. So we'll go to the next one. This definitely looks like a lot more back and forth. You'll notice it's a high-level port to a port 4242. And if we kind of go back to this here, that's the port that we were looking to call back on. So this is probably more likely what we are looking for, or it's going to be at least the start of it. And that does look like it. So what we see here is that the attacker then got basically bin sh, can't access TDY, job control turned off. They then issued the ID, and the server responded back with the user ID where it's at, and then they did a PTY spawn. Then they listed the directory. They catted out the overpass file. They sudo to James, and then there is James' password basically. So this person had James's password, and that might have been derived from that, and we'll have to maybe see that later. So what password did the attacker use to privilege escalate? And that was it. How did the attacker establish persistence? So we can look back at this TCP string and see if they did anything else here. So they catted out Etsy shadow. They did a git clone of an SSH backdoor, it looks like. They did a keygen. Looks like they executed some kind of backdoor and it put put some kind of file there. So let's see what they're looking for. Something with a colon and a couple slashes and a dot there. So this GitHub, that's kind of what it looks like to me. All right. So next one is saying using fast track word list, how many system passwords were crackable? So for that, again, we're looking at what the attacker did, and they catted out the Etsy shadow for us. So if you've never seen Etsy shadow, the way this is going to work is these are the user accounts, and then this is the hashed password. And then this could be like a user ID, forgetting the whole exact format. So I don't say anything wrong. There you go. So username, then it's the password, and the password. Let me make this a little bit bigger here. The $, whatever, then $, indicates what algorithm was used. So let's look here. So on these, the algorithm is 6, so you'd have to, again, look that up, and that tells you that it's SHA-512. Number 3 tells you day since January 1st, 1970 that the password was changed. Minimum number of days required between password changes, maximum, and then worn, inactive, and expired, which they don't even have on there. So based on that, what the only accounts that we even really care about would be these ones that have passwords. The other ones that don't have passwords on them, we're not going to crack. We're not going to get anything from that. So there's no point of even copying them over. So we'll go ahead and copy this. We're going to go into the terminal here. We'll have to open up another one while this is still running, and we'll save that in here. So we can just call this shadow. We'll paste those in there. Okay. All right, and then the next thing that we're going to want to do is look at cracking those, right? So we can do John. We'll do shadow -w equals user shared word list. We'll do rockyou. And see what we get out of that. So we got one already. Another one. So on a small CTF or something like that, if you're again looking for points, we can take some educated guessing here, right? Like we looked at the password list. We know there's only 4 users, so not too hard to kind of figure that out. Um, Based on evidence already, we know we have 2, so we could try 2. That doesn't work, then we can move on to 3, and then 4. So apparently we're gonna be able to crack all the passwords, which is amazing. It's just gonna take a little bit. So again, that's something that you'll kind of learn, as you go through CTFs and stuff like that. Is sometimes if you're looking to score the points the fastest, depending on the CTF or whatever, you'll just do some things just to kind of get the answer, especially if there's no penalty or whatever. Those we're gonna leave those to kind of to keep cracking. And let's go move on to the next task here. So for the next one, it's asking about the backdoor that we found. So something that we could do is we could look at, let's see here. We could pull up this GitHub and see what this backdoor is about and get a little bit more information. We'll copy that here. We'll just use that same tab that we were looking at for Etsy. Okay, so should be used for legal purposes only. Only in systems you're allowed to. So it doesn't give you really anything on the main page. That's the raw file. That's the build. Main go. So there is a hash string. Is that the one it's looking for? Whoops. Does look pretty long, so let's see if that's going to be it. All right, so that's the hash, default hash for the backdoor. Again, using tools like this and stuff like that, you really want to read the code. You want to understand what you're doing. Um, knowing that this has a default hash, even though you think, oh well, I'm gonna log in exactly right after that. Um, after using this backdoor, you kind of put at risk whatever system you're using this as, because there's probably definitely bots that are sitting there scanning consistently on the internet looking for this port, and then um, looking to see if this, if they're able to kind of basically log in, and use the same type uh, hash or password or whatever it is. And this is, happening consistently on the internet all the time. So don't use something that you just pick up off of someone's GitHub. What's the hard-coded salt for the backdoor? So for salt, that's going to require a little bit of looking at the code here, right? So we can look through the code here and try to determine that a little bit. So let's just, so there we go. So the function called verify pass has a hash, a salt, a password string. Okay. And so now we need to look for verify hash, which is down here. And so again, not only are we using like a hard-coded hash, we're also using a hard-coded salt. All right, what was the hash that the attacker used? Go back to the Pcap for this. So looking at the back door, he did a keygen, backdoor -a. So that looks like this was it. Perfect. All right. Next one is crack the hash using RockU and a cracking tool of your choice. What's the password? So we are still cracking the last one. We finally got the third password there, but we'll go ahead and work through this. So let's see here. We have a hash. So we can copy this hash, and we can just put this in another file. Let's go nano ssh underscore backdoor dot text. Paste that in there. Save it. And then let's try to get John on that one. So because we're using John in the other terminal, we could specify a different pot number or pot or location. So basically, it can work out a different area. The recovery file is locked. Okay, so let's say John-H. We could maybe specify a recovery. Let's make this bigger here. Dun, 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 dun. Let me look at the man page real quick and see if I can find something. So maybe session. Session looks like we could maybe do it that way. So let's try, we're gonna do -- pot and then -- session. And we will do, there we go. So hopefully that won't take too long. There we go. Looks like it didn't. Um, that did not look like it figured it out. All right, let's edit the file and add the salt since that's probably what it's looking for. So again, we would get this from here. That kind of looks like the salt. Maybe also that the whole thing didn't go over correctly, so we'll have to try that. Alright, we want to paste that and then put a colon there, and then let's also try the whole thing, because it looks like there might have been a possible line break there or something. So what we'll need to do is take out maybe the less than sign there. So we'll paste that in and we'll try that. Like that, and then we'll paste it again for good measure, and we'll put the salt at the end just for good measures. Okay, so let's try to crack that again. So we're definitely still waiting on that. And it still did not look like it cracked. So we must have something not fully correct. So additionally, what we could try to do is specifying different formats for John. We can look back at the code here and kind of see what format it's potentially using. So it does say hash for backdoor, okay. We could do maybe a hash identifier. So we can copy this. Okay, so I think it's thinking that SHA-512. We could try to add the salt on it and see if that makes a difference. Let's try that. Okay, so 9D is what it's thinking the salt is based on what we think it is from, that it's potentially that there. All right. Oh, you know what actually the salt would be this one, wouldn't it? Because that's the hard-coded salt there. And then the hash is, we're providing it basically. Yeah, so they did hash and the salt. Okay, so maybe that's why we're not getting it either. So let's try this. Let's also put the salt there. Whoops. Put the colon before, and then we'll grab get this complete hash. Okay, and then delete these extra characters. That should be a good line there. All right, so we'll save that. If we cat that out and look at this last one. So now I think this is going to be it. And so again, this is sometimes the thought process of how to kind of look at these things. And so now it's saying it's an unknown hash type though, which that doesn't seem right. All right, let's try that and see if that's going to crack though. So still backdoor, still session. Still trying to crack the other one. So we could try to move on a little bit and see if we can answer some of these things. we'll need to, of course, hack our way back in. So we're going to need something, or maybe use that hash to use a SSH backdoor. We can try that. The attacker defaced the website. Which the message did they leave in the heading as a heading? So we can go there and see if the site does anything. So that should be the IP address. Oh, probably helps if we connect to the VPN. All right. So now we're connected to the VPN. We should be able to access the website. There we go. So the message that they left as a heading. Oh, probably this one here. Nope, it was the other message. All right, there we go. All right, let's see if the password's cracked. Again, we're not really getting anything off the passwords cracking, which is a little bit concerning. Make me wonder if we got the full hash. All right, let's see what else we could do. And then, all right, so we're just copying what the attacker typed in. We're not copying the response back from the server this time. And again, we'll put in the salt here. We'll save that. We'll also edit it and just put that hash or stay with that hash. Maybe we have too many different ones and it's not picking it up, right? Alright, so let's just delete the whole thing. Okay, one more time. So we are copying the hash from here. That is the hash the attacker provided. Okay. Based on the source code, this should be the salt. That hasn't changed. Okay. Yes, and we'll just call this new. Yes. Okay, now we'll do John, but we're going to do underscore new. Alright, I think we're going to try to specify the format here, because it doesn't seem like it's detecting it. Let's see here. That's going to be dash dash format equals, we're going to do SHA-512. I think that's fine. Okay. So there's salted SHA also. So we'll try raw 512. And so there's the hash there. There's a username colon hash. Username colon hash and then a bunch of colons after. Specifying 512 and dollar signs. Alright, let's try that. Raw shy of 512. Alright, did not like that. Let's see. I need to put something new. Nope. Dash 512. SHA-512. Yep. It just needs to go before everything. John can get very particular about where it wants the options and stuff. For the example, it had it here. Alright, try Hashcat. I don't know if it's gonna work on this system, but we'll give it a shot. Okay. 1710 -a equals 0. And then we need to copy, paste. And try the salt. Okay, and then it says user share word list, rock you. All right, well that's going. Let's try something else. Okay, so we're still cracking this one here. I'm gonna go ahead and open up another terminal. Let's go ahead and download that backdoor and see if we can get access to the system using what we saw from before. So we'll do a git clone, similar to what the attacker did, right? So we're cloning this, and you know we have what they did on the system here. They also, yeah, they SSH as James. On that port. And so does James's password work? So let's try that. So we're going to try SSHing as James. 124. And again, we need to specify the port. We'll do yes. We'll put in that password that we had for James. Okay, so that does not look like that's going to work. Let's try typing it out. Yep. Okay, doesn't look like it. So might have been a different password then. Okay. We're gonna try some other things. Be right back. All right. So it took a little bit, but figured out how to use John to crack the password. So what we're going to do is specify a word list for John. We're going to specify a format, and the format is dynamic, and we're telling it that it's SHA 512, but the way that the text in the file is going to be password first, and then salt after that, and then that's going to read in the actual file that has that, and then we're specifying to use a John pot file in the local directory, and then specifying a new session. And we'll look at the test.txt so you know how that works out too. So it cracked it now, but let's look at the test.txt and see what was causing a majority of the issues. So we have the hash from before when we were looking at the Wireshark, and so that was the hash here. The key that we needed to do was we needed to separate that with a dollar sign, similar to what I was trying to do before, except I was using a colon instead of a dollar sign. And when you do the dollar sign, then there's the salt after that. So what John's looking for is that as the delimiter, and that's what basically this is saying up here is I'm specifying the password first, and then you're going to find a delimiter, and then anything after the delimiter is a salt. So that was the trick there. That was what was kind of taking a while and figuring out. So we'll need to get this going again. So let's get that machine running. All right, and go back to the task at hand. So now we have the password. And so sometimes that's what you got to do when you're, up against a wall. Just take a step back and come back to it. Um, and then, you'll be able to sometimes find a different solution or do a little bit of research and find a good solution. All right, once this box comes up, we'll give it a couple seconds. So just to kind of recap where we've been at so far, you know, we analyzed the Pcap file. We were able to find that the attacker found an upload script in the development URL. They then uploaded a PHP shell. PHP code that had a reverse shell in there. Then on the attacker's machine, it basically shoveled the shell back to them on port 4242. And then they apparently had a user's password to escalate privileges. So maybe there was some phishing involved, or some kind of way that they captured the credentials from before. And then they established a persistence using this SSH backdoor. This SSH backdoor is public code, and through the analysis of the code on the second task here, we were able to find how the kind of backdoor works and the way to kind of basically crack that password that was used by the attacker by reviewing that code and putting it through John. So now that the box is up, let's go ahead and see what we have access to and what ports are open. So we'll use Nmap. We're going to use the IP address. Usually I'll put it, in a targets.txt, but because of the way that we're running with this box, we'll just put it in the IP address. Again, doesn't matter either direction that you go. We're going to do default version. And let's have it run some HTTP scripts. Script dash timeout equals 2min. And then we want to do SV, so service version, AO, and output all formats. We'll call this Overpass. Detailed. So dash SV is service version, dash A is advanced detections, dash big O is OS detection, dash little o big A is output all formats, which is XML, Nmap, and greppable. The script is, again, these are categories of scripts. So default version involves a category. The HTTP asterisk is basically every script in Nmap that starts with HTTP will be ran. And then we were putting a timeout so it doesn't take forever. And we'll need to do sudo. So from before, we already knew that port 80 was open. Part of the task that we had, we have the two different ports there, 22 and then 2222. We now have James's password. Originally, I thought it was the one that we saw in the capture, the one that he used to escalate, this one here. But what we're going to do now is try that new one that we just cracked from here. So the backdoor again kind of gave us that password that he used after we cracked that. So we're still even working on the original one, and that's been running for a while. So we'll SSH as James. So 254.4. And again, we need to specify that extra port there. We'll say yes, and then we're going to use, it was November 16, if I remember right. All right, so we're in as James now. Finally, we finally got access to the system. We're able to um, use his credentials that we cracked from before there. So interesting kind of banner to kind of tell you that to run commands as administrator, use a root, use sudo. That usually, yeah, maybe be a sign to kind of let you know that you can sudo as James. So I'm typing in James's password. Apparently it's not the one that we used SSH in. So that must just be his SSH password or the backdoor for the SSH password. So we'll copy the other one and use that one instead. Let's try that again. Yeah, so neither one of those are working, which is interesting, being that we got access via SSH to it. All right, so for the task, what we can do is it's just asking for the user flag and then root. So what we should do is go ahead and keep to our process, right? Um, let's go ahead and get linps running. Look for different ways to, potentially privilege escalate. Again, it's a very thorough tool, so that's definitely something that's going to check multiple different areas for us to have that possibility. While we can, while that's running, we can hunt for the user flag elsewhere. So let's split this terminal up. I'll do another SSH as James, and then we'll go from there. 254.4. So again, we're just putting in the password. So now we have two terminals, so we can do more work. I'm going to split this one off and basically upload linps to it. So if you were not made aware and again, used to kind of using this process, linps has been updated, but the original script or things that it would check with would do an automatic exploit for kernel level stuff, and if that you did that during the OSCP, you could actually get dinged and not get the points for the flag. It has been fixed, and OCP's you know response to that is, again, you should know your tools. Um, so there's a mixed crowd on that, but always be aware of that type of stuff, especially if it's for an exam has hard set rules. In a real pen test, not gonna matter, right? Like that's the thing, and I think that's what a majority of the community kind of harps on a little bit is in a real pen test, it's whatever tools necessary that you can do to get the job, pending that you're not putting customer data at risk, you're not creating a backdoor that other people could use, or you're introducing more vulnerabilities. That's just the nature of an actual pen test. You use whatever you're comfortable with and whatever gets the job done. So if that's Metasploit, that's Metasploit. If it's, Empire, that's Empire. If it's LinPs, then it's LinPs. All right, let's go to so there we go. 10 to 12 to 19, 80, 81, and we want len ps.sh. There we go. So we can close the web server. We'll exit out that terminal. Now we have that here. There's also the backdoor program, but so we need to make linps executable. So chmod plus x, then linps. So now if we look at it, you'll notice that it's green, indication of it. If you didn't have colorized terminal, you could do ls-al, and that's gonna show you the bits set for each of the files there, and you'll see the X for executable. Okay. So what I like to do then is run linps, and then we can also tee that off into a file, and we're just gonna put linps .out. So what we're doing is we're piping the output of linps. T is basically going to show it on the terminal, but also put it into a file, and so we'll be able to see it while it's still running. Okay. So we'll give that a little bit of space. We're not going to need as much down here. So for us, we're just going to kind of look and try to get that user flag. So there's the user flag, and easy peasy. All right, and then we're gonna wait to see what we have for linps here and see how we're gonna escalate our privileges. Okay, looks like it's done. So again, this also, like I said, displayed everything on the terminal, but it's also now saved in that out file. So if I need to pull that file down to my system, I could do that and do analysis that way. So maybe if the terminal is not a full terminal, or I have issues and I can't see everything, like I can only scroll so much, that's why it's always good to kind of put it into a file. All right, starting at the top here once we get there. So Linux version 4.15, generic, Ubuntu 7.5. We do have a sudo group. On the box is ping and netcap. Run at 18.04. not the most out-of-date version of Ubuntu or anything like that. So, again, you could look up kernel exploits or something if you wanted to for that version. 64-bit architecture, so again, nothing crazy. But if you had to do like a kernel exploit or whatever, that's good to know. Some useful software. So we can see that there's NC and then also netcat, wget, curl, ping, base64, Python, Perl, PHP, sudo. There's a built-in compiler, GCC 8. So if you had to compile code, we can see that the backdoor is already running on there. Then there's our commands that we're running with linps. There's the Apache server running this server and SSHD. Network information, again, here we're looking to see if it's, inside of a container or anything like that or attached to something else. So we only have one interface and it's the only thing with the IP address, so that's good. One service is running only via exposed to localhost, and that's 53. Not a big thing, not really going to help us out there. We see that there's no additional ports that we did not discover during scanning. So users with console, here's your users that have a console on the system, then the full list of users. There's the encrypted method, so that that correlates back to what we were looking at when we saw the Etsy shadow password file. If you remember, we're still cracking that, but the $6 again denotes what algorithm is used to hash the password, and this is also confirming that there. Which again is nothing wrong with SHA 512. The problem is that the users are using passwords that are not complex, or that were discovered basically in a breach or things like that. So that's more where I would tailor the finding, is that users are not required to use complex passwords. I'd actually write that up and say that. Some interesting files. So majority of these are going to be your system files, but this one stands out right there. So we'll want to look at that one. Again, it runs as root in the root group, but it's in James's directory there. Same thing with the GID. Also, it's pointing out that sudo may be vulnerable. There was a sudo exploit that we could use as a backup or attempt to. So again, it also highlighted it here. There is a backups directory or backup folder. And these are all just headers. And then this is just looking for anything that says password or PASSW, which could be a lot, especially on a web server or whatever. It doesn't need to specifically have a password, but okay. So again, that was pretty quick. We didn't even really get much into the other terminal using it before LinPs was done. But it's good to have that just in case it does take longer. So the main thing that we saw was in James's home directory. He had a file that again has this root privilege, but it's readable and executable. The main thing is that it's executable by everyone, and that's more the vulnerability on this one, is that the permissions is not set correctly on this, and it runs as root. So this is your typical SUID and GUID bypass or whatever. So if we do this, it should be uh, what's that special character? And then -P. All right, what? Oh, I put another slash. That's what I messed up on. There we go. So it's just basically someone had put this bash type shell in this uh, directory, and it had root privileges. That's what you'll see here. The S means on that and on here. So the group had special privileges, and then the user had special privileges, and then it's world executable. So then that allows us to basically run this and keep that permissions of what it's assigned to it, which is root and root. So with that, then of course, then the next part is to go to, oops. And if we look in there, we can cat the root file. If I could spell. There we go. So pretty cool little box. Again, uses a combination of having to read a Pcap file and then use the same kind of technique that the attacker did before to gain access. A little bit of shakeup with John, because again, John's format for SHA 256 is different, so we had to use that dynamic rule, and that kind of gives you a little bit of exposure of doing that with John, which is usually, if you're limited on your resources, you can't just use hashcat all the time. And I think that's a majority of things that I saw out there is, just use Hashcat. But you saw on the system that we're doing the password cracking on, Hashcat doesn't work that great, and it doesn't work on every system. So, you got to be versatile in other tools to be able to do that. So I hope you learned some stuff from the video. I definitely learned something. I definitely had to go research a little bit more on John and being able to use John to crack that password. Um, I remembered something to that degree, but not the exact details on how to do it. So definitely a learning experience. Uh, Thanks again for sticking around, and hope to see you on the next one.